Hello? Yeah, I hope you're doing great. And it's right and high time to continue a little bit with what we discussed previously in fiber optics communication. And I wanted just to remind you a few things. I was going through what we discussed previously and realized some things that I would want to point out to you. So you should take this into account so that everything goes well. Number one, we talked about near infrared wavelengths. Near infrared wavelengths that are necessary or are utilized in fiber optics communication, and I mentioned the 850 nanometer. I mentioned 1350. It is 1300 nanometer. So I think I had some mistake in my in our previous discussion. It should be 1300 nanometer, and the third one is still the same, is 1500 nanometers. Now, with the wavelengths, I said that these wavelengths are the ones that are mostly preferred in optical fiber communication. That is very right. And the main reason is because these three wavelengths, you remember previously I talked about the issue of wavelength being a property of the medium. You can remember we discussed about this formula. V equals to V equals to, let me correct this a bit, V equals to F omega. And we said F is the property of the source, and also we said wavelength lambda is the property of the medium. Property of medium. This is the property of the medium. And the most important point here is when light of a particular wavelength is shined onto a material, that wavelength is affected in different ways. So we have light ranging from, let's say, visible to near infrared. Each part of this light, when it shines through a material, the light is affected differently. And because of that, it is very important to analyze and identify and understand the kind of wavelength of light that we use for fiber optics communication. Because of this same thing, that when we talk about wavelength, it is the property of the material that light passes through or interacts with. I want to make this point very clear. So when we consider near infrared light that is used for fiber optics, these three wavelengths were chosen specifically because glass, which is made of silicon dioxide, is not highly affected at these wavelengths. Yani, what I mean exactly is, when you shine the wavelength of 850 nanometer, when you shine the wavelength of 1300 nanometer, when you shine the wavelength of 1500 nanometer, these wavelengths are less affected by glass when they are being transmitted. That's why they are chosen. So if we could choose another wavelength, let's say, for example, maybe 2500 or 1600, at those wavelengths are highly affected by glass. It means if that is used in glass for fiber optics transmission inside the glass, that is going to be highly affected. But these three are chosen particularly after understanding the properties of glass with respect to these wavelengths. These wavelengths are less affected by glass, so we can expect to transmit them through glass and get the perfect signal for a very long distance or through a very long distance without deterioration. That is something very important. And I would like to actually finalize this kind of a revision of what we did previously by talking about, we discussed also about light sources and light detectors. We talked about light sources. And also we talked about light detectors. We talked about LED being one of the light sources and laser. We talked about several light detectors, but what I want you to understand mainly is we discussed previously about a lot of detectors that are used for detecting light. In particular for fiber optics, you shouldn't mix this or confuse this. In particular for fiber optics, not all the detectors that I mentioned previously are utilized. No. You should take that into account. There are some of the detectors that I mentioned in the previous discussion that actually is utilized for fiber optics, but all the other detectors are utilized for detecting light in other applications. In particular for fiber optics, I talked something about PIN, P-type, intrinsic type, and N-type. And I mentioned something about indium, gallium, arsenide. This is PIN type. Indium, gallium, arsenide. Indium is P type, gallium is I or intrinsic type, and N is arsenide. And also another one that is very crucial is APD. APD is avalanche photodiodes. So it works using the principle of avalanche breakdown. Avalanche photodiode. So these two are actually the wavelengths, no, not the wavelengths, the detectors that are mainly applied with fiber optics communication, when we want to detect light in fiber optics communication. So we have CCD, but that is used mostly invisible in other parts. We also have silicon detectors, which are also used in other parts. But when we talk in particular or specifically with respect to near infrared, especially when it works with fiber optics, the detectors that are used are PIN detectors, P-type intrinsic, N-type semiconductors, and APD avalanche photodiode. And an example of this is indium, gallium, arsenide, a combination of several things together. But as we discussed again, I would like to reiterate this. Near-infrared detectors are expensive as compared to the detectors of CCD that can be used in visible part of the spectrum. These are things that I want you to take into account as we move forward. Thank you.